Today we're going to work through lesson 10, exercises 3, 4, and 5. In this first one, we have the mass of the Earth and the mass of Pluto. And it asks, compared to Pluto, how much greater is Earth's mass? And that tells us that we're going to take Earth's mass and subtract Pluto's mass. Since this is already written in scientific notation, I'm going to convert this one as well. 1.3 times 10, and then there are 3, 6, 9, 12, 15, 18, 21, 22. And then I'm going to look at the 2. This is 10 to the 24th, and I'm subtracting this number. I'm going to go ahead and move the decimal 2 places this way, increase it, and make it 10 to the 24th. And that will give me a decimal 0.13. So I have 5.900 minus 0.013. And these are both times 10 to the 24th now that I've rewritten them. When I subtract that, I get 5.887 times 10 to the 24th. I double check this is correct scientific notation, so I can add my label and have my final answer. Exercise 4. Using the information in exercises 2 and 3, find the combined mass of the Moon, Earth, and Pluto. That tells me that I'm going to add these 3 together. The mass of the Moon is 7.3 times 10 to the 22. The mass of Earth was 5.9 times 10 to the 24 in the word problem. And when I started here, my original scientific notation was 1.3 times 10 to the 22 for Pluto. So since these 2 are already 10 to the 22, I'm going to change this one to, I'm going to decrease, move the decimal to the right, and make this 10 to the 22nd. 1, 2. So that means that over here, I'm going to write 590 times 10 to the 22. And since these are combined, I'm going to add, and that will give me 598.6 times 10 to the 22. However, this is not correct scientific notation, so I have to rewrite it. 5.986 times 10. I move the decimal to the left, which means that I am going to increase it to 10 to the 24th. Okay, number 5. How many combined Moon, Earth, and Pluto masses? The answer to exercise 4. Oh, I forgot to put my label on my answer to number 4. Let's make sure we do that. Are needed to equal the mass of the sun. So how many times will this number fit into the mass of the sun? That means I'm going to divide. So if I look back at exercise 2, I get 1.898 times 10 to the 30th divided by this answer, 5.986 times 10 to the 24th. Again, when I multiply and divide, my bases do not have to match. I'm going to divide the decimal part first, put that into my calculator, and I'm going to round to 2 decimal places. So my calculator has 0.317, and then the decimal continues. I'm going to round that to 0.32 times 10. I take these 2 powers and subtract the exponents. 30 minus 24 is 10 to the 6th. However, this is not proper scientific notation. I need to move the decimal 1 place to the right, which means that my decimal or my power of 10 is going to decrease. So I will rewrite it as 3.2 times 10 to the 5th combined masses would fit in the sun.